Okay, so we are live. Okay, so yeah, I suppose. Okay, at least it shows. Okay, so it seems to work pretty well. Yeah, I think that it's pretty normal. I just will also record the screen because I will have some video, so works perfectly. Yeah. Okay. I don't think that we cropped too much. Okay, but still we have to wait 5 minutes. 5 minutes. Yeah. So okay, okay, so there are quite few people involved. So as I understand, this is just very brief review. I have no idea. To be honest. Okay, okay. Yeah, it's a very good question. Yeah, yeah, yeah. Mm-hmm, 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 mm-hmm. Okay. Mm-hmm. Mm-hmm. No, no. I wasn't, trained for that. But I think that I have to. Yeah, yeah. So, uh, no. Yeah, yeah. I hope that I'll fit everything in less than. Yeah, yeah. Someone can speak. But yeah, we'll try hard to maybe even less. Because you also have some exam. Or not? Is there some exam at the end of the semester? Yeah, of course, not today. Yeah. Yeah, because I remember this last time I get requests to, to make 1 or 2 questions for it, for this topic. Yeah, yeah, I know. Yeah. I haven't replied to them yet. It was too early, but I suppose that I have to because I make this idea. Yeah, so this, I wasn't, I'm not responsible to organize it, but I think that, yeah. So if you would like it, I can just make exactly that. Okay. So I think that we are in time. Yeah. Okay. So sound seems to work. Video seems to work. Everything seems to work. Here we have the presentation. So let's get started. Okay. So welcome everyone. My name is Grzegorz Orzechowski. Yeah, however, almost everyone call me here Greg, or maybe from the obvious reasons. Yeah, I work together with Aki in a laboratory of machine design, and recently I get especially interested about how to incorporate different artificial intelligence techniques within the mechanical engineering. And today we'll discuss this topic a little, yeah. So it will take a form of some kind of preview to this topic, yeah. Uh, if I understood properly, yeah, in the next semester there will be some continuation of this course, yeah. And if everything will go fine, we'll extend those AI topics in mechanical engineering also to this course, yeah. But like here, we hopefully will spend just like 1 hour about this topic. For this course, we'll spend just few lectures and hopefully do something useful. Okay, so today our outline is pretty easy. I will start kind of, I call it theory, but we will not deep too much into theory. Yeah, it will be rather of overview of the methods. Yeah, what is AI? Why to use it? Why not to use it? And similar topics. And then we'll talk directly about mostly about some applications of the AI in mechanical engineering that we are performing, okay, and what and how we are applying all this to our mechanical engineering world. Okay, so maybe you have seen this already. Yeah, have you seen it? Okay, okay. Hmm? Okay, it doesn't really matter, but what matters is that that we are here and we talk also about artificial intelligence, software development, and all of this because world is changing, yeah. And now of course still it's important to build a solid machines, yeah, but currently it's not enough typically, yeah. Economy is changing, the requirements to put extra values into our into those designs, mechanical designs. And artificial intelligence is one of the areas where everybody, or at least many companies, yeah, are very, very interested in to put this, and they see the potential into it. Yeah. But because you have seen it, so there is no point to discuss about this. So I suppose also you know that part, that currently, hardware, like of course phones are quite obvious device that they used to just be for calling, but now they are for yeah, many other stuff, yeah, as we know, yeah. But the same, it goes beyond this, yeah. So for sure it's available like shown here into the cars, yeah, where you have just this kind of services, yeah. So you have to pay for service, like if you want to have this auto drive or some other stuff, or in some BMW cars if you want to have heated seats and some entertainment systems. And of course the dream would be to be able to extend this trend as well to mechanical engineering, yeah. So why not to have excavator? So we have excavator or some material handler or some tree harvester that works as usual but can do also some extra things. And for this, we believe that one of the ways is to go with AI. Yeah, so we'll discuss about firstly what is AI. Yeah, then I will talk very briefly about some impactful AI applications. Yeah, on general terms. Uh, I will present just from to show some theory about one of the most fundamental techniques for data-driven techniques and machine learning and artificial intelligence, that is about neural networks. A word about reinforcement learning because we are using this, and then we will go through the things that we are doing here in our department. So let's start about the question: what is AI? So what is AI? Oh, okay. About those, yeah, yeah. So I suppose that, I hope that it's not about, you are not laughing about me, but about those photos. Yeah, okay. Because, yeah, as you have seen, maybe there is a note here. Then many of those images that you will see today, especially in the first part, are created using Bing Image Creator. Yeah. So sometimes you can have nice fun here, like this photo. I created it today. Yeah. Sometimes, they are getting better. Yeah, but still they cannot count well. Yeah. Like those fingers looks totally different. Yeah. And so like here I generated by asking, to generate it by putting what is AI. Kind of it serves the purpose. Yeah. What is AI? Yeah. But yeah, yeah. But in general, so what is AI? Yeah, yeah, of course. Yeah, 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 yeah. Yeah, this is one of the things. Yeah, it applies more, shifts a little towards machine learning, but for sure, yeah, yeah, yeah. Any other comments? Hmm? Mm. Yeah, of course. They have typically some decision-making abilities. Yeah. About this, okay, I will get bigger. But about this, this sounds to me like standard programming. Yeah, that you have algorithm because of course all the algorithms works in one way or another in that way. But this description, like that they have algorithm that follows the step in certain order, sounds like more traditional methods. Of course, they are also can be included into machine learning, uh, but yeah, 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 yeah. Yeah. And other ideas? Yeah, yeah, this is one of the definitions as well. Yeah, so there are many definitions. Yeah, so of course, yeah. So I think that in practice, all of you are right. Yeah, yeah. Depending on which direction of this vast field you will take a look. Yeah, because yeah, especially there are many definitions once again, yeah, and they depends on if you we talk about acting like a humans or another direction that it's more that it's nicer from the perspective of engineering field is acting in rational way, yeah. And here you can see some of those definitions, yeah, like acting humanly. The studio how to make computers do the things which at the moment people are better, yeah. So then it is about the direct relation to the humans, yeah, or acting rationally. Acting rationally is nice because it's easier to set a goal. Yeah, because you want to tell that, for example, do this in minimal time or use minimal energy. So yeah, from engineering perspective, it's nicer. Yeah. So like study of design of intelligent agents. Yeah, very general because all those definitions are very general. Yeah. Here I put this note that we go from percepts to actions. Yeah. So we want to have this intelligent agents. Yeah. That can interact with environment. Yeah. So like with our world. Yeah. Typically we do this most things in the virtual environment, but the goal of course is to get to real environment, have perceptions, it means some kind of measurements, be able to make reasoning, learning about this, and perform some useful actions. Yeah. So from this perspective, so we want to have some intelligent agents that know where they are, can make some measurements about the environment and perform actions that are useful. Okay. So just a few notes, general notes about AI. Here is about why is AI worth studying. Yeah, I don't know if there's reasons to convince anyone, but for sure there is always some kind of skeptics about this because soon we will talk where, when, and why not to use AI. But of course, one of the reasons why we are here, why we are discussing this, and this was at the very start, it's about, rapid technological advancements. Yeah. So we are where we are with our designs, with our machines, but when we get to the software side, we can get a lot of added values. Yeah. Wide range of applications, of course. Yeah, you take your phone and whatever almost you open, you have some AI system working there. Yeah, career opportunities. It's just more practical way. Yeah, there's like with the programmers, there is never enough good well skilled AI specialists. Problem solving potential, of course. One of the reasons why we want to get it, because we want to have our problem solved in automatic manner, so we don't have to bother about this. Interdisciplinary nature, quite clear. Yeah, it ranges from art through some voice processing to image processing, programming, and many others, and mechanical engineering, like we are here. Global impact and influence as well. It's changing a lot, yeah, in better and in worse ways, yeah, because one of the things that is issue is that AI is very advanced technique, yeah, so it really requires quite a bit of effort and work to get into it and to apply it. So the companies that already were applying this in the past are ahead of the others, and it's really hard to catch on, and it requires a lot of resources and a lot of money as well. Future proofing skills, again, this is important from the career opportunities. Any questions? I suppose it's, yeah. Why and how is AI overused? So another way, of looking of this, because yeah, there's also some not so nice things about AI or in general how it is used. Yeah. So we want to use it because it's popular, but because it's popular, there's always tendency to just overuse it. Yeah. So there's easy to find a way just to use it everywhere without really analyzing and thinking if some more traditional methods are better suited, yeah, or more conventional, or just some alternatives, yeah. So reasons for reduce is just data-driven trends. So it goes about, what is the hype now? We talk a lot of about data everywhere. So that's why there's tendency, if you can generate some data, let's see and try to use AI. On the other hand, there is always the issue that if you won't try to use it, you really don't know if it is applicable. Yeah, because it really needs some experience and to know where to use it. Funding and publication. Yeah, so this is more related to science. That simply by using those techniques, it's kind of sometimes easier. Yeah, but you can believe me that it's not so trivial and easy um, uh, to be visible. Yeah, to propose something. But of course, there is also another thing that it also will create some kind of skepticism because of this. AI as a solution to complex systems. So this is this way of thinking, yeah, that if we have some problem, yeah, let's try to use AI and see what will happen. How it's overused. In education and training, it's overused, yeah, because it's I use education and training in two places, yeah. So first of all, that how it's overused, yeah, because in education it's just especially now easy to relate to AI solution instead of trying to really solve it, yeah, and we'll see some examples here. Neglect traditional scientific methods, exactly that part, yeah. So without getting a good knowledge of underlying terms, try to apply AI. Lack of transparency and interpretability, one of the issues, yeah, because I suppose that you have heard that AI often produces so-called black box solutions, yeah. So it's just hard to tell, how it works exactly, where it is applicable, and especially that like we are also using all this in the simulation, then if we will go to reality, will it work or not, yeah, and when it will fail, especially is it robust through changes, big issues. Reproducibility issues, yeah. So where you have the set of your equations, yeah, and some model, then you just open MATLAB or whatever program, Python, Julia, yeah, and then you can just code it, yeah, run the simulation, and then you should get exactly the same curves, yeah. And this applies to many things, yeah. If you have some, yeah, when you are solving equations, finite element models and others. But here there is a lot of randomness included into those processes, yeah, generating data, adding noise, random initialization, and others. So it's and those the range of parameters is huge. It's really hard to get exactly the same results or even similar results, yeah. Like I was discussing about, there was one very nice method about graph neural net with my colleague, if they were trying to use it because they were doing some song modeling. Yeah, they said, yeah, many times, but it always fails. Yeah. So you go to the paper, it shows, just those beautiful animations for the fluid, yeah, and it works for them. And here it doesn't work. And it can be just some small details that it's not mentioned here and there. Addressing overuse, of course, education and training, and just we are part of here. Yeah, so proper education, so to know where to use it, how to use it, and I think that especially that now with the vast variety of those tools, it's once again important to be there and to understand this. Especially that we can use ChatGPT. Yeah, I also use it, as a help to generate like those images and some of those informations here. But at the end, we as people that deliver it are responsible for all those things. Yeah. So we have to know where it used, we have to check if it works properly, and so and so. Critical evaluation of AI applications, exactly. At the end, humans are responsible for what they deliver. So they have to, be sure that all developments are proper and works. Transparency and open science. Yeah, it's connected with this reproducibility issues. Yeah, so to deliver the code, yeah, for example, to be able to check it, to see the details and regenerate the data. Okay, so it was a lot about this. So yeah, um, I don't know about all of them. Yeah. For sure, the most famous one, OpenAI ChatGPT, is closed. And it's closed to the level that of course, the roughly architecture is known, but details even of this architecture are unknown. So, for example, if you want to just know how large are those networks, yeah, how many parameters that are used, those are only speculations. So many developments are open, yeah, like there are many of those smaller projects like Llama that you can use even locally, and there are many models, even those language models that can use, yeah, just download to yourself, yeah, and then you can be sure that it works on your data, your computer, and it doesn't go anything. But with some like this open AI and ChatGPT, you don't know. Yeah. So yeah, this is part of the issues. And of course, about applications, just very shortly because they are everywhere. Yeah, this is diagnosis drug discovery. Yeah, so this is one of the remarkable that you can just yeah, help in aiding doctors. Yeah, or even there are techniques that can just create new drugs. Yeah, based on the how the old ones were created. The same applies for chemistry, for example. They create a network that will fit with the data of existing those chemical reactions, and they were able to predict new ones. Autonomous vehicles, growing trend, of course. Yeah, language translation and models, very big things that make a huge disruptions everywhere. Yeah, including education, retail, and e-commerce. Yeah, everybody get those nice suited ads for our shoppings, at least most of us. Robotics, of course, yesterday I have seen that, just outside those doors, there was, those cleaning robots, yeah, that was driving through the university, and there are in many other places. Entertainment and media, when you listen, Spotify, Netflix, whatever, they creep the database and, make the predictions what you like, what you want. And so climate science, this is pretty interesting, yeah, because like I have heard that like 3 years ago, if you were asking about if there will be able to predict weather, climate, or whatever about the data, everybody says no, yeah. But now big companies like
exactly like Facebook, Google, or Microsoft are included in there, yeah, and they're creating the large models that, based on the already existing data, can predict weather pretty well. Yeah, so this was a huge change. Education, we are here. Artificial creativity, yeah. So, like for example, this very nice photo, yeah. However, I don't know. Have you tried to use this kind of image creator? Yeah. So I must admit that, from my perspective, already to make a phrase that will create this kind of nice photo is a form of art. Because I haven't put it here, but the phrase was like this long, yeah, and I don't know how much time it would take me to create something like this, yeah. Because from when I put what is AI, okay, this is understandable, but the results are not so great. But to get a nice result, of course, it works, yeah. Everything requires a skill, also using large language models. Yeah, so that's why education. Okay, so finally, how it can be used in mechanical engineering. Yeah, in many ways. Yeah, you will see this, but here are some examples. Like creating more efficient and optimized designs. Yeah, so it's already working. Yeah, so there are methods, optimization methods, or some other nicer method that that work with our mechanical models and can optimize designs, simulate complex physical phenomena. Yeah, we are trying to do this. It's not so easy, but the promise is that after you get through this painful state, you are able to do this just nicely and effectively. Predictive maintenance and quality control, big topic and good interest for the companies. They really want to have those techniques, included in their machines, yeah, because with predictive maintenance, you don't wait when it breaks, but you just change the parts just before it breaks, and it makes a huge savings, avoid downtimes, and really nice service, yeah, if works properly. Robotics, automation, manufacturing, yeah, already working in many places, just tries to expand in many others. And aids in discovery and development of new materials. Just one idea, the same like it works with the new drugs, the same like it works with the new chemical compounds. Yeah, it can works with the new materials. Yeah, it's just closer to our field. Uh, Enhances capabilities of control systems, machinery, and vehicles. Yeah, this is very closely related to what we are doing and what we want to get from it. Yeah, because uh, maybe you have heard that people are great, yeah, in controlling those machines, but there are few drawbacks, yeah, of you using human operator. Have you heard about some drawbacks about using them? Yeah, yeah, yeah. Of course, yeah. Yeah. So yeah, of course. So then it hopefully goes connected with the safety, yeah, with reliability. But there is even, yeah, it is a very good point. They're also, far trivial, like how to find all the operators here, yeah. And you train them for 5 years, yeah, and they work in those harsh conditions, like I don't know, yeah, but even like today's weather, yeah, I wasn't very happy that I just have to drive here and there, yeah. So, and what to think about, spending few hours in the forest in poor lighting conditions, out of the network, and having to do stuff. Yeah, so this contribute also to burnouts, to errors, and many other stuff. So there's a lot of things that we want to address. Maybe not even by replacing because it's not feasible now, but also by aiding. Yeah. Also, just to put some extra safety measure, get some extra information and help with this. And has interface between human and mechanical system, exactly that. Yeah, so maybe you can detect when someone is tired, yeah, or just provide some information. Our colleagues from machines, I don't know if you have seen it, make some kind of this haptic feedback system. So they were even able to perform some operations like loading, yeah, blindfolded. Yeah, just based on the information. Of course, it was in the simulation system, but based on the information from two joysticks. Yeah. So yeah, there's a lot of interesting things that we can do. Okay, so very shortly about neural network. Yeah, those slides came from our collaborators from Austria because they just make it nice. So I haven't seen a reason why to change it. But okay, neural networks. Do you know what are neural networks? Yeah. So we have those units. Yeah, small computational units. They are called neurons. Yeah. Typically, they have some weights. Yeah. So when you connect many other neurons to that, you get some signals. You multiply it signal about something, then you sum it up, and then you apply some activation functions to it. Yeah. So those are the basic building blocks. Yeah. And then they're arranged in this kind of network that when you have firstly, of course, the input layers, when you put your signals, then you have some middle layers, yeah, where the signals goes through it, and then there's some output layers, yeah. Good thing that, in principle, it's very easy, how they work, yeah. So they can also be parallelized very efficiently. They can be properly optimized, and they can vary in size really, like it's written here. Yeah, when you have some kind of simple control system or some simple approximation, you need like 1, 2, maybe 3 layers at most, and it works perfectly fine. Yeah, but for some heavy image processing, you can just stack up like 500 of those networks, and then you have this kind of huge behemoths. And of course, for those large ranking models, you go even further. uh, any questions? Yeah. There's a very simple principle how it works. Yeah. Uh, in general, they have very nice properties. Yeah, like it's written in the first node, they can be used to approximate almost everything to any degree. Yeah, if you have something that is measurable. Yeah, yeah, and of course you need to. There must be a correlation between input and output. They can approximate everything. Yeah, so whatever you will put to the input, if you make training arrangements and number of neurons, so design of your architectures properly, you should be able to get correct results at the output. Typically, it's easier to say than done. It requires typically many trials, yeah, some tunings. But it can be done. So that's why they are called as well, some kind of universal approximators, and that's why they also work very well. Of course, the drawback is that you have some processing, some huge matrix of those weights, but it typically resembles this black box architectures. Yeah, that it processes this data somehow. This is travels through this network, especially when it's a huge network, but it's sometimes just hard to tell exactly what it's doing. But yeah, this is the how it works. There are various different types of those networks already. Like the most standards are like here that you have just those neurons that are connected together in the multiple layers. This is so-called multi-layer perceptron, the most basic. Feed-forward network signal goes from the input to the output. Without many changes, but there are many others. Like for image classification, there are convolutional neural networks that applies typically some kind of the filters, and learn those filters to get some features from it. In the reinforcement learning, because we are interested in this, typically we use just this kind of simple architectures. There are also many others, like there's many of those recurrent neural networks that feed forward the data, yeah, and are very good in learning long time series. They are also included in those large language models a lot, yeah. And also the size matches very much, yeah. Here is then about large language models. Yeah. And here's a graph, very small graph about, how it goes through the years. Yeah. So about the how are the sizes and number of network parameters. Yeah. And so network parameters, it means that, in practice, okay, so first of all, those parameters typically stands between those connections, because all this connection has some kind of weight, yeah. But in practice, after learning, it also serves like a kind of memory. Yeah, because when you have those weights, then processing is done in proper appropriate scheme, appropriate way. Yeah, this is of course, but it is already learned, so it acts as a memory. And as you can see that the number of those parameters get from I think it was just scaling in billions, yeah, from zero point 0.1 billions up to 1,000 billions that are approximated for the newest one within those range, yeah. I don't exactly remember, the numbers, but I believe that just electricity bills for training ChatGPT 4.0 was approximated for like $100 million just to pay for this training. So they are just huge. Yeah. Any questions? That's why it takes pretty long to get any kind of information. And many of them you can use at your computer, but you still have to have quite a lot of memory, yeah, typically. And it takes, hmm? But for what? Yeah, but you ask what? Yeah, ChatGPT? Yeah, of course, yeah, it works because then you have just web interface. Yeah, I'm talking about when you want to run it locally on your phone or computer. Yeah, of course, there are models that can do this. Yeah. Hmm? About this, yeah. Yeah, you can ask ChatGPT about this, for example. Yeah, so I don't know. Yeah, so I Google it. Yeah, just because. Yeah, if you want to have some reference, um, yeah, let me know and we can find it. Yeah, because yeah, yeah, I typically just Google or ask ChatGPT currently. And and but of course some of those data is just approximated like for just GPT-4, yeah, because there is no exact data because like we discussed nobody really tells. Okay, just very briefly, yeah, because I don't want to dig into it, but this is what stands behind those large language models. And as you can see, it's pretty complicated. Yeah, so it works well. Just like our brains are pretty complicated, already those techniques are also pretty complicated, and they are based on so-called transformers. And transformers typically are based on some attention mechanism. Attention mechanism, it's kind of mechanism that works in a way that when you have a sequence, like a sequence of words, yeah, it tries to find out which words are important and then bring them to attention. And then other words are considered not as separate entities, but are considered in relation to each other. Yeah. So that's why if I ask about transformers in AI, I can get this kind of information. But if I will ask about transformers, already I thought that it will start talking about those those modified cars. Yeah. Hmm. Yeah. Okay. Okay. So so it's hmm? Yeah, because I wonder how to answer it directly, because uh, I think what makes it AI in comparison to what? Okay, so first of all, it follows the definition, yeah, that it acts pretty well, yeah, because you provide it with the problem and it provides you solution, yeah. So this is one hand. Another hand is that of course, all those systems are somehow architectured, yeah, but they just went through those extensive learning periods, yeah. So there wasn't the case that there was someone who tells that here are those kind of those weights. Yeah, there are also far too many parameters, like because like we get to those thousands of billions, then it's far too many of them. I'm not sure why there is a doubt that it's about AI. Yeah, it's based on those because I think that rather the whole process of training, yeah, because also any of those entities I typically somewhere put it into AI stack, yeah. But of course, single function or single process doesn't make AI, yeah, like because single neuron, like the most basic neurons, I don't know if you know, they are just now most one of the most effective functions is just ReLU function. I don't know if you know it. Yeah, ReLU function is just a piecewise linear function that looks like that. Yeah, that here have zero and then it's just linear increase. Yeah, so it has just linearity in this form that it's not continuous. Yeah, so here like that, yeah. And this is the element that makes a neuron typically, yeah. And then you know what happens with the neuron, yeah. But when you connect many of them, because then you already get AI system, yeah. So, uh, but it's pretty tricky and philosophical question because it can make reasoning. But I think that we are starting to get a little into philosophy already. Because on the other hand, uh, none of those is required to get AI because now AI talks a lot about data, about learning and decision making, but none of those is it's strictly necessary to make AI system. Yeah? Because when we have some expert systems, the early expert system were also considered AI, and they just people gathers some experts, yeah, and tell if this, then do that, yeah. So and they also were the system that works, yeah, were engineered, and they were also AI. Does it answer somehow your question? Okay, perfect. Yeah, thanks. So okay, but I hope that we can go further. Yeah, yeah, it's pretty complicated, of course. And uh, here. This is result of using ChatGPT, yeah, because I tried to ask it. As you can see, the title is similar. Understand so about visual representation of what are transformers in AI. But at least for me, it wasn't really helpful. Yeah? So it looks nice, so I included here. Yeah, but there is still a long way to go. Especially even if you take a look, it's not because of the really poor resolution, but even it's not super readable. All those texts. Yeah. So yeah, there is still some way to go. On the other hand, it's pretty interesting. Yeah, at least visually is pretty appealing. Not that it makes sense, but yeah, it works well. Okay, something a little more technical. Yeah, that, as you may know, those language models can be used for programming. Yeah, and here is some example that you can just write something like that. Consider a mass spring damper system with the following properties. Yeah, about mass, stiffness, and damping. The force applied to the mass is given. Create a simulation model using SciPy to simulate the dynamics of the mass spring damper system. And when you copy paste this to those large language models, yeah, typically you can get something useful, yeah. And now when I type this today to see how ChatGPT 4 will react to it, and I get this plot from the simulation that was generated, yeah. Maybe I will just show it to you. Okay, so I suppose that I have to move it to another screen. Yeah. So as you can see, so here I put this node to. Okay, can you see this? Or is it too small? Maybe I can increase it. Okay, I'm not sure how to increase it. So okay, it works. Yeah. So when I ask about this, so from especially of those, because I also check another system that is much smaller that just runs on my computer, yeah, and it just generates some code for it. But here you can see that I was surprised, even how it works, because firstly, it discusses about the problem, yeah. So then it shows what equation will be solved, then explains all the things that are appearing in this equation, yeah. So it explains the method. So it was introduction. There was the methods shown, yeah, with data explanation. Then now we have going through to analysis of the results with those concrete numbers that were provided in this short text descriptions, including, the information that we assume that this force is constant, which is pretty important here. Uh, Next, it shows description of the program that we have this kind of second order differential equations and will be solved for OD using SciPy. And it even described the procedure because you have to lower the level of our system from second to the first. Yeah, so it uses this kind of substitution and exactly how it works. And now, uh, and this is just a result of the code of the writing the whole program in the Python, executing it, and generating this plot. Yeah, and all this based on this short text, yeah, and some extra explanation, and even some conclusions. So it behaves like a really nice student, yeah. So if I were to get this kind of the report, I don't think that I would have too many complaints. No, it's 4.0. Yeah, yeah. So it makes a difference. Yeah, yeah, yeah. It makes a difference. So there's even no code, yeah. So even it just hide everything and it just I always tell my student, don't show me code in the report. It's pointless. You send it other way around, yeah, already. So why to put it in the code in the report? And it's also just it's there. So if you really want to have okay, the code is there hidden into the link because in practice code is as important as result it provides, yeah. So maybe for inspection it's good to know it. But well, works pretty well. Uh, okay, I think that I just have to hide it. Where is my cursor here? Yeah. But it works for ChatGPT 3.5 as well. Maybe it doesn't work in the way that it doesn't present all those nice features and explain everything to you and make it like this report case. Yeah. So, but it solves the task properly. Hmm? Yeah. 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 But here we ask about the Python. Yeah. But yeah. 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 Exactly. Okay. And very short note about reinforcement learning. Do you know about reinforcement learning? What is it? Okay. So uh, this is kind of, let's say, algorithmic procedure. There are many methods for this. In order to make agents that learn from making actions from the environment. Yeah. So maybe you have seen already some kind of examples. Yeah, that you, for example, make some kind of the simple model like and ask him to walk. Yeah. And the issue is that you doesn't tell him how to walk, yeah. But for example, you give him some information that he behaves properly. It's called this reward here, yeah. By, for example, rewarding it for moving center of mass forward, yeah, or something like this, yeah. Uh, this is the way to make controllers, yeah. This is called also learning with delayed reward, yeah, because you don't care too much about reward at the moment, but what this approach cares most is about the reward collected from the long time, yeah. So you have good reward, but then you get penalty because you, for example, crash into human, you don't want to follow this path, despite earlier it went fine, yeah. There, you almost grabbed this tree, but in the middle there was something. Yeah. But yeah, but and it works that way that no, that's why it's also trained on the computers typically. Yeah. Um, because you give the information that there are a set of actions that you can perform, yeah, and it tries different set of those actions and try to figure out how to make those actions in order to get the highest reward, yeah. And it also, of course, includes the state, because you have to make those observations, and this also shows, one of the way here, at least, when we were talking at the start about definition of the intelligent agent, yeah, that is this kind of entity that can get information from the environment. So you have to make some measurement and then make some reasoning and perform useful actions. It almost looks like this kind of image. Yeah. So reinforcement learning is pretty nice, but again, it works nice, requires a lot of data, of course. So this is kind of the drawback. How about safety? We do not discuss about this at the time. Yeah, but we try to figure out how it works nicely with the thing. Is it more or less understandable how reinforcement learning works? Okay, perfect. Uh, and of course, about the education, at least as I understand in this university, the students are typically encouraged to use those techniques like ChatGPT and others, AI to learn them because you have to learn them. Yeah. Uh, I like ChatGPT mostly because it really saves me a time from Googling the things. Yeah, because now when I typically when Googling, yeah, you go those articles, you have to follow like 10 pages of the introduction to get something, and then you figure out that it's not very useful. Yeah, and in ChatGPT, can you provide the information? It takes like minutes, so it's really nice. There are of course, Bing solutions from the Bing chat and image. Uh, by the way, I was also wondering, how, of course, because relating to your question, how Bing chat relates to GPT-4, 3.5, 4.0, and others, and the answer was that most likely is that one, as I suppose that it also means that it's not so well known. There is this another thing that you can test is GPT-4 All. Have you heard about this program? Yeah. Hmm? For GPT-4 All? At least I haven't paid for it. Are you sure? Yeah, it's a totally different thing. Yeah, yeah, of course, you have to pay for ChatGPT 4.0, and for 3.5, you just pay with your data, yeah. But GPT for all is just, I think this is open source initiative. So you download the client for large language models, and then you can download some of them and use them locally, yeah. And even it works that way that you can ask them to make, that you can use the information contained in your data to answer your questions. They're much smaller models because they have to fit into your computer, and typically, like that one, it's not really a supercomputer with a lot of GPUs, yeah. But it also can provide reasonable solutions, yeah. So it's something also worth testing. And about AI, of course, the most popular is using Python AI stack. But is there here anyone who haven't used ChatGPT? Hmm? No, no. Sometimes no. Sometimes no. I have heard it now. Yeah, we're in the meeting, and there was question if someone is using it, and almost everyone, raised their hands. So, and the conclusion was so the only ones who doesn't raise their hands, they just haven't listened the question. Yeah. So yeah, yeah. But there was one brave man who told that he haven't tested this ChatGPT. But yeah, why I don't know. Yeah, but now yeah, everybody uses it. Of course, you have to know how to use it, and but be also aware that you are at the very end responsible for it. Okay, any questions? Yeah, I didn't make some kind of this systematic comparison, but there is visible difference. Yeah, yeah. Yeah, 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 they are. Yeah, and if you, yeah, for sure, this is the case. The model is much larger. Sorry. Hmm. Of course. Yeah, yeah, but sometimes, you have tendency to get into the loop, yeah, that, you, they have problem with counting and, yeah, yeah, you can guide it, but yeah, but work smoother, provide, more realistic replies, and in general, it works significantly better, yeah. Uh, yeah, so and when you have there was some kind of work when we have really complicated models, yeah. When ChatGPT 3.5 fails, 4.0 works. So there are really applications where you have to use it. Yeah, yeah, but it's much larger as well, so there's a lot of developments, extra development included. Well, okay, in theory, all those models works in the way that they just, tell the next word, yeah. But somehow it works, yeah. I'm not sure because if it's all only about this, yeah, that it's weighted better because of course they is weighted better, but mhm. Yeah, but okay, yeah, but it's also based on I think the fact that just capabilities are larger, yeah, because it has better memory, can pay attention to more details, and but yeah, yeah. So I suppose that yeah, depending how to talk about this, yeah. But okay, so I will just go through some of the things and examples that we are doing here, and maybe also some of our colleagues, yeah, especially that it starts with the colleagues, yeah. So this is one of the inspiration, that starts that when you try to drive with this car with with some poor control, it never works. But then when you include some models, and try to predict those paths into the future, it works far more better. Yeah. So this was our inspiration that came from the game industry because as you know, the people are doing a lot in the game industry. But of course, automation of machinery, automation of everything, it's not an easy task. Yeah. So it's divided at least into a few stages. It's divided typically into this kind of at least 4 stages. And some of the parts we can deal with automatically, algorithmic pretty well. With some we can't. Yeah. Uh, we, as our group, typically are trying to do the things at the very end. Yeah. So task definition is pretty difficult because task definition tell manage the forest, for example, in our region in South Karelia. Yeah, pretty general. Then task planning would be something that cut the trees in this forest, yeah, or even select which trees to cut. This can be partly planned, by the system, because you can create the system that will recognize which trees to cut and then select them, so it can be done. But uh, we are not dealing with this. The next ones gets into actions, yeah. So first step is localization and mapping, yeah, because even if you know where is the forest, even if you know what trees to cut, yeah, you have to get there. You have to find this forest, get to this forest, and then start acting, yeah. And then we have this simultaneous localization and mapping, yeah. So it means that you at the same time localize where you are based on odometry, based on GPS and other stuff. And when you put yourself on the map, then you make this mapping by using some cameras, lidars, or other sensors just to figure out what is the environment. Especially that that one of the characteristic that it's here, yeah, is that by using heavy machinery, or most of the machinery, you are changing, constantly changing the environment, yeah. Because if you cut the trees disappears. If you do some excavation, the material also is moving, and all this will be changing, yeah. And at the very end, when you find yourself that you are in the correct forest, you have found the correct trees, yeah, you can just make the direct interaction in the environment, so decide how to, how to grab this tree, how to cut it, and where to place it. Yeah, and hopefully, this will work that way. Uh, this shows more or less, about, how the control levels are now and how it changes with the time. So of course, with the time, the control level increases. So the things that works pretty well, like now, is of course those low level control, like control on the position level, yeah. So you can control pretty well where are your joints located, yeah. If you have, for example, this excavator, it can be done, I believe, even using some PIDs, maybe some more advanced techniques, especially if you get to endpoint control, which is much nicer as well for operator. Yeah, so this is the first thing. So instead of bothering, that move this arm and that arm, yeah, you are rather thinking, where to move directly your end effector. Yeah, which is yeah, just much nicer. Yeah, we also think, about how to move our hands, from here to here, and we do not bother, how to bend our muscles or something like this. Yeah, it works pretty well as well. That is something like obstacle avoidance. Yeah, that you would like the system that when it's moving, from this point to another, that doesn't hit anything. And this is already, something that why those first two is just about the machine. The next, if you go to obstacle avoidance, you start caring about what's happening outside, the machine. So with the environment, so we already have some kind of information and sensors, to get those. But even with some proximity sensors, this can be solved. Yeah. And then what we want to get, we want to get some, go even further, So how to handle, like in the forest examples, the log directly, yeah. So put this log from here to our trailer. And at the end, make the full cycle automatic. So about the full log logistics, within the country, for example. Okay. I suppose that you cannot hear because I can hear this in my how to change this. Okay, I have to change to voice to speakers. Yeah. Okay. Just nicer effect, I believe. Yeah, with speakers. Yeah. But I suppose that you also it's likely that you have seen this or something like that. Yeah. You know what is Meva. You know what they are doing. They are doing those simulators, and they looks pretty amazing. Have you tested them, by the way? Yeah. Yeah. Yeah, I don't know. I think it's really nice, Yeah, and it really works pretty nice, and you can feel that, that for example, like here, that you are grabbing this, and it's not going so nice, especially if there is those 6 degrees of freedom. You really feel like you can tip over your machine. But okay, yeah. So of course, we wanted to use this kind of simulator and use them with AI, and it appears to be pretty complicated. Yeah. So of course it's nice. It has some those nice mechanical formulations, yeah, with those hydraulic actuators, with the ground interaction, with those particles, and all this works, and even you can make some meters there. But when you want to make this into the environmental control system, it seems that this is also a business by itself, yeah. So um, And of course, the reason why we want to use simulations, I think, is pretty obvious because here you can see that you can do this without simulation. But like they claim, there's not many universities that can buy, for example, 100 or 1,000, excavators, just to put them in the field and try to learn them to perform those actions. Yeah, we have zero of them. Yeah, maybe you can buy some, make a project to get a one. Yeah. So Google was able to purchase, some tons of robots and then ask them to perform this kind of pick and place actions and use them as example. But this is rather exception than the rule. Yeah. To make this automation, to make it reverse learning, you need a lot of data. And to get this data, unfortunately, it takes awfully a lot of time. Yeah. And okay, I will check. Okay, not really comments. I just want to check if there are none, there are not so comments that, I cannot be heard or something. So yeah, so generate synthetic data, and after that predict the future. So because hopefully our models are representatives and so and so, yeah. And we have to do this in proper way, yeah. Like I tell more or less, it's a little challenging because all this looks nice, yeah. But once again, so Meva makes nice simulators, but as you can guess, those simulators are done for humans to operate, yeah. And so when you want to and the kind of things that you want to get for machines is slightly different, yeah. Like machines operate well with depth camera, humans not necessary, yeah, or from some infrared sensors, many other settings, yeah. And also uh, efficiency is big issue. They run in real time. It's great, yeah, because you don't need a lot more, yeah. But if you want to get this reinforced learning, yeah, now with using different simulators, we are able to uh, make in 1 hour of the walk time, yeah, like 80 days of simulations, yeah. And here it's impossible. Okay. Okay, once again, let's click it in proper order so it works as it should. So okay, and now you cannot see it. It's even worse than it was. Yeah. Mm. Okay, okay, okay. Yeah, but I hope that the next one will work better. But okay, so it works. But as you can see, you should see, yeah, that the issue with this solution is that it works only for this one setup. Yeah, so it's not really transferable to anything useful. Yeah. And by the way, along the way we have done many different things. Yeah. So here there was the idea of how to use simulation to find a proper way to climb about the wall. This was done with one enthusiast of this wall climbing. Yeah, it works somehow. Uh, Seen this? Yeah, okay. Okay, okay. Some seen, some not, yeah. So this was mostly the project created by my colleague, Adam Kłodowski, yeah. And it was about, the simulation of the humans. It's also a big trend, how to simulate the human everywhere, yeah, because, they are just needed, like here, the idea was kind of how to use this kind of human simulations for assembly line, to figure out how to arrange the assembly line and how to arrange the assembly process together to make it efficient, ergonomic, and so and so. Um, well, our actuators are really sophisticated, it seems so, and it's really hard to replicate them, whatever. Of course, this is quite early process. It's hard to find a worker that would just go this way and another and just pick one piece each time. But yeah, you have to start something somewhere as well. Uh, oh, here is just the simple application that we have, about, that of course we can talk about everything, but here there is the question, is this printed properly? Yeah, we get this question. It's came from AI from the direction of this machine vision. Yeah. So the question is it correct? And then how to fix it? And, yeah, just, many things are happening. Uh, Monte Carlo tree search. Okay, so this is also this is the technology behind this application. You have seen with this car, yeah, because it uses Monte Carlo, so it uses this kind of random simulations, and it uses tree search because it's building a tree. Yeah, have you heard about this method? It's very famous because of AlphaGo, Alpha Tensor, and earlier attempts to play chess. Yeah, yeah. It seems that AI specialists really like games. Yeah, so they because but they really like games because even when they ask them, but maybe we can apply it to some physical devices like those machines. No, no, no. Games are fine. Yeah, so yeah. Hmm? Yeah, 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 of course. Yeah, then yeah. And it somehow works, yeah. So we're even able to, control our favorite example of pendulum, yeah, even double pendulum, because if it doesn't work with pendulum, why to bother to go anywhere else, yeah, even further. But yeah, yeah, like with everything, it's quite promising. So let's see. This works about the searching, yeah. Uh, more than learning. But I think that that is the important distinction that you have part of the things that works on the learning level and searching level, and the good and if you want to have something really working properly and on the large scales, all those techniques have to be combined. And here we apply even more pendulum and even more reinforced learning, yeah, to those pendulums here with discrete control. This trains on a standard computer like in an hour or 2 hours. Yeah. Here with continuous control, at least it's much smoother. And then of course we went to double pendulum. Yeah. To see. Have you ever tried to keep a stick on the finger? Yeah. So try to keep 2 sticks or 3 sticks or even 4 sticks. Um, it's not something that can be easily solvable even using traditional control designs. Yeah. So even if we were able to get some solution with the 4 pendulums, one over each other, but this, as you can see, requires some tuning at least. But the great idea is that okay, if it works for those pendulums, hopefully it will also work for those excavators. Uh, Here, those are not our examples. They came from Isaac Jim. Have you heard about Isaac Jim? Okay, because Isaac Jim is pretty niche software because this is the software that is uh, designed to be used for reinforcement learning. Yeah. Have you heard about physics? Maybe if you have played anything. Okay, because Isaac Jim is created by NVIDIA because they sell a lot of those graphical cards. So the idea of the Isaac Jim is how to make simulations that are somehow physically plausible by on the graphic cards. Yeah. Uh, because it's really hard to make simulations on graphical cards. Yeah, because you have seen those methods, all those matrices, and all those iterations. Yeah, and there is a lot of decision making, looping, and some complex operations. So nothing that really fits well onto GPU. Yeah, so they are specialized in it. They use special techniques for it. Maybe they are not most accurate in terms of physics, but they just work well. Yeah. So they move the whole simulations on GPU. by why it's important. Yeah, it's important because of two factors. Yeah, and one of the main factor is memory transfer, because learning is done on GPU typically because you have a lot of data. So those neural networks are on GPU. And traditionally, in most cases, simulations and other processing is done on CPU. Yeah. So we have to make a simulation, then send all this data to GPU, process the network, that get back from the CPU without, for example, the actions in reinforcement learning to CPU and repeat it many times. And because you repeat it many times, it really takes fully a lot of time to send those data back and forth. Yeah. So here, by using GPU, firstly, you don't have to send this data back and forth because they are staying in one place. So this is really huge saving. And also, as you can see here, uh, they increase this improve this parallelization by allowing to model like thousands of models at once. Yeah. So this is the reason why we are able, for example, to model and train this kind of the system, within the 1, 2, or let's say few hours of wall time on pretty standard PC with not so modern graphical cards, that is equal to some weeks of simulations of this kind of devices. Yeah. And they even start to do something useful. Yeah. So after those few hours, and it's really hard to make them work, as you can see now. So it grabs something, but then there are some glitches. So it's improving, but it's really those are the weeks of work to adjust it to work it in proper way. But it really makes a difference. Like in here, if you spend 4 hours, and then you get equivalence of those weeks of simulations, data for weeks of simulations to make something useful, instead of just waiting those weeks to see that it's not working, like here. Yeah. And here just some finalizing that also there are some smaller projects, yeah, like here about hydraulics, because that one, of course, this is typically hydraulically operated forwarder. But for the need for this exact sim, they do not support hydraulics, of course, yeah, because again, those models just must follow what they allow for it, and there's no easy way to get those additions because of CPU. I mean GPU. On CPU, what is easy on CPU is not necessarily easy on GPU. So here, one thing that we are working is how to simplify very heavily the system. Yeah. So instead of using those very stiff differential equations, I think just with this one force works pretty well. Yeah. Um, okay, here is directly a slide from one of our colleagues about flexibility. Yeah, so how to create those nice surrogates for the flexible models. Uh, Another promise is that so why of course to use it when you can get those flexible models pretty fast, because you can get them even faster. Yeah, and if you add all those savings on here about a little about hydraulics, yeah, here a little about flexibility, then you can just train the things that were not trainable earlier. And here is also our trials for the same, here. So here is the model of the crane that is in our laboratory, this Batu crane, and how to model flexibility. So how to know where is the end effector. Because with humans it's easier, yeah, because with the humans you have to have those machines, those 10-meter arms, and the operator will just see, oh, it's here, so it's a very good place to drill a hole. But when you automate it, and then when you have this flexibility of like 10 centimeters or 20 centimeters, it starts to be a problem, and it seems that manufacturers don't know exactly where is the end effector of their machinery. And that's all, yeah, from my side. So this is the things what we are doing, uh, and yeah, so Uh, as you, I suppose, know after this course, we follow the simulation-centric approach. Yeah. So we believe in simulations, but now the term of this digitalization and how to make added value from the software development came into play. And again, so how to combine those trends of the digitalizations, it came along with those artificial intelligence, with the simulation, and how to make new products out of it. Automation is challenging, and we have seen all those examples. Maybe those pendulums work pretty well, but they are not working as well always. Yeah, and if you want to get something more troublesome like this log forwarder, it takes a lot, to make it usable. Can it solve our problems? Let's see. It looks promising. Yeah. So now it's time, for application of this into the machinery and in our mechanical engineering world. Okay. Yeah. So it's everything from my side. Any questions, comments? Mm-hmm. Mm-hmm. Quite a bit. Of course. Yeah. Of course, not everything, but that's true. That's quite a bit. Mm, no. I think okay, maybe not necessary, of course, not necessarily equally, but you have to bring quite a bit into it. Yeah. So for sure, you have to know how to program. Yeah, in some of those languages. But even uh, yeah, so you have to know how to program. No, because you have to know. Of course, all if you create many of those models, uh, we typically create quite big programs just to make it. And if you are better at managing those programs, so know how to make them nice, it's better. Uh, on the other hand, this situation, seems to be the problem for many, many decades. Yeah, because okay, now it's AI, but there are many others, uh, so it has different phases. Yeah, so simulation software is done typically by engineers, which doesn't typically has those degrees in computer science. That is, most of them doesn't, and they still are writing some really huge and amazing projects that involve those parts. Yeah, so it's very nice addition, but practice shows that it's not strictly necessary. I'm sure that it will make life easier on the longer term, but you can deal without it. From another perspective, most of the companies currently are in part software companies because you simply cannot avoid it. Yeah, like every producer has the division that is devoted to creating the control systems. Yeah, and this is one of the very important branches now. How to make the control system better and better. I hope it answered at least partly your question. Yeah. Oh yeah, yeah, yeah. MATLAB is very classical, so I don't. Python is not so. Yeah, yeah. So there are uh, uh, many of them will work. Yeah. C for AI, not really in most cases. Yeah, for sure we can do everything in C like in any language. But from practical perspective, like MATLAB or Python are more useful, because they have interfaces into those libraries. If you want to build those libraries, of course you can go there, but it's not the way to go. And so yeah, Python I think is the main language that it's used. Uh, MATLAB is, I think MATLAB lag a little behind it, yeah, but now I think that also work pretty well. But I think that, directly I'm not sure if the language technology is the most important, because, knowing the principles is, yeah, it matters a lot. hmm I don't, yeah, I don't know, yeah, because, you have to do some programming for it, yeah. Can you avoid it? Not really, yeah. But one thing is okay. On the other hand, one thing is interest in programming, and so I wouldn't say that it's something that that should discourage you. Especially okay, because I have heard this nice anecdote that in practice, from the perspective of computer science, they do not consider the engineers that the engineers are writing programs at all. Yeah. They tell that the engineers are just trying to pass the code somehow through compiler. Yeah. So, but some basic programming is needed. hmm Yeah, I don't know, because the topic on belief is hard to follow. Yeah, but I think it's good to try it. Yeah, because it surprises me quite often. Yeah, because I'm used to the thing that the programs are not very smart, but sometimes it can really deliver the answers. There was very nice story of my colleague that he was looking for very simple question. He was looking for question something like, what is the best material for screw to secure some kind of electric connection? And he tells that he was searching, googling for like 2 hours. And there was all those articles writing some different stories, and but nothing really brings the direct question answer. So then he tries after those 2 hours ChatGPT, this 3.5, yeah, and 2 minutes, and then bam, you have an answer and proper one. So, so yeah, I think it's worth trying, really. And and of course, you can be concerned about those. There's always concern about those privacy, yeah. But I think just to try it, it's pretty okay. Yeah, you don't already have to ask about some very sensitive things, especially in engineering field. Yeah, you can ask ChatGPT, as far as I know, to prepare some presentation, of course, to prepare some report. You can even ask to make some slides in Beamer, yeah, or some others, Markdown maybe. Yeah, yeah, but there are text-based slides techniques. Yeah, you can use like Markdown and then generate slides out of it. You can use Beamer, like in LaTeX, uh, or some others, HTML. Yeah. So yeah, so that's true that I think the 3.5, cannot read, something more than plain text. But yeah, with plain text you can do a lot still, because 4.0, as far as I know, it can read already quite a bit and generates photos like here. Yeah, yeah, that's true. But it's also pretty useful because typically it really takes quite a bit. Sometimes it has tendency to use awkward wording. Yeah, that's true. But yeah, well, those models are very good on summarizing data. But it's really also important, So what is this book about? Or what is this article about? Yeah. Or what is this course about? Yeah. Okay. Any other questions? Okay, if not, then thank you a lot, and yeah, see you around. Thanks.